Yes, we'll see an example on Fourier series. We have to find the Fourier expansion of the function f of x is e raised to x in the interval 0 less than equal to x less than equal to 2 pi. Now we know that the formula to find Fourier expansion of a function f of x in the interval 0 to 2 pi is given by the formula f of x is equal to a0 divided by 2 plus summation n is 1 to infinity an into cos nx plus bn into sin nx, where we know that a0 is 1 upon pi integration with limit 0 to 2 pi f of x dx. Remember, whenever it is asked to find Fourier expansion or Fourier series of a function in the interval 0 to 2 pi, then we do not check whether the function is even or odd. Directly we apply this formula. We find a0, an, bn using the respective formula and substitute in this formula of Fourier series or in the formula of Fourier expansion. We know a0 is 1 upon pi into integration with limit 0 to 2 pi f of x dx. Note that when the function is defined in the interval 0 to 2 pi, limits of the integration are 0 to 2 pi and the multiplier outside the integration is 1 upon pi. So now in this case a0 will be 1 upon pi as it is, integration with limit 0 to 2 pi as it is. Now here in place of f of x, it is e raised to x. We substitute it as e raised to x. We know that integration of e raised to x dx is again e raised to x. So this is the formula we have. So integration of e raised to x becomes e raised to x, and this term is within the limits 0 to 2 pi. You see, 2 pi is the upper limit, 0 is the lower limit. When we put the limits, we'll put the limits in place of x. Remember here integration is performed with respect to x. So in place of x we have to put the limits, and always we'll put the upper limit first in place of x, then the lower limit. And remember it is always upper limit minus lower limit. That means you see this 1 upon pi, will keep it outside as it is. In place of x, first we put the upper limit. When you put upper limit 2 pi in place of x, this term becomes e raised to minus 2 pi. Then there is a minus sign, it is upper limit minus, then in place of x we write the lower limit, which is 0 in this case, which is upper limit minus lower limit. In place of x we write the lower limit, it becomes e raised to 0. We know that e raised to 0 is 1, e raised to 0 is 1. So therefore we get this as 1 upon pi into e raised to 2 pi minus 1, or you may write it as therefore a0 is e raised to 2 pi minus 1, this whole term divided by pi. So see, we have found out a0, value of a0 we have found out. Now we have to find an and bn. Now first of all let us find an. Now to find an, remember the formula to find an is 1 upon pi integration with limit 0 to 2 pi f of x into cos of nx dx. So this is the formula to find an, and see if we substitute the respective values. So this is, remember, the formula to find an when f of x is defined in the interval 0 to 2 pi. We substitute the value of f of x. We know in this problem f of x is e raised to x. It will be e raised to x into cos of nx dx. Now remember we have a formula, integration e raised to ax into cos of bx dx is e raised to ax upon a square plus b square into bracket a cos bx plus b sin bx. This is the formula that we have. We have this formula. Now if you compare this integration with this, so this formula with this given integration, you see in the formula it is integration of e raised to ax into cos bx dx. In our problem it is e raised to x into cos nx dx. Compare the powers of e, you will find in the formula it is e raised to x, in our question it is e raised to x. So here in place of a it is 1, in place of a it is 1. If you compare the cos term, in formula it is cos bx, in our question it is cos nx. So in place of bx it is nx, so it means in place of b it is n. So a is 1, b is n. If you apply this formula, see the formula of e raised to x cos bx, if it is e raised to x, we write this e raised to x as it is here upon a square plus b square. So in our case it is e raised to x, so it is going to be, see this 1 upon pi, I'll write outside the integration as it is, and after applying this formula, first we have to write e raised to ax as this. That means in this case it will be e raised to x upon a square plus b square. That will be 1 square plus n square as it is, into it is, if it is cos nx, then remember, or in the formula, if it is cos bx, we write first cos bx and then sin bx. Now in our case it is cos nx, so it is going to be cos nx and then sin nx. First term we multiply by a, second term we multiply by b. Here a is 1, b is 1, b is n. So it will be 1 into cos of nx plus n into sin of nx. And this entire term is within the limit 0 to 2 pi. You see, here we have applied this formula. First we write that e raised to x as it is inside the bracket. See, first we have to write cos and then sin of the same term nx. So it is cos nx and then sin nx. First term we multiply by a, that is by 1 in our case. Second term we multiply by b, that is n in our case. Correct. So we have applied this formula here, substituting the respective values of a, b. Correct. Now, see, we'll have to substitute the limits. See, when you put the limits, remember, it is always the upper limit minus lower limit. See, we can write this as, first of all, before I put the limit, I'll write this as this 1 upon pi as it is. This will be e raised to x upon 1 plus n square. 1 into cos nx is cos nx plus n into sin of nx. Correct. So these are the limits 0 to 2 pi. So this 1 into cos nx will be cos nx, n into sin nx will remain as it is. First of all, wherever there is x, I'll put the upper limit 2 pi. See, if I put the upper limit 2 pi, this 1 upon pi as it is, wherever there is x, we'll put 2 pi. So see, it will be e raised to 2 pi upon 1 plus n square as it is, into cos of n into 2 pi will be n 2 pi, or you can write 2n pi. Because of 2n pi plus n into sine of 2n pi. See, this is when you put the upper limit. We have substituted the upper limit 2 pi in place of x. Wherever there is x, we have substituted the upper limit. Okay. So this bracket is for this one, for the entire term. Okay. Now this is the upper limit minus lower limit. Now we'll put the lower limit 0. Wherever there is x, we'll put the lower limit. So this was upper limit. We substitute the upper limit 2 pi in place of x. Now minus, it is always upper limit minus lower limit. I'll put 0 in place of x. So it will be e raised to 0 upon 1 plus n square into cos of 0 into cos of 0 into cos of 0. Yes, so we are substituting x is 0 here. It becomes e raised to 0 upon 1 plus n square into bracket cos 0 plus n into sine of 0. Okay, the upper limit minus lower limit. ये पहला टर्म कैसे आ गया? We substitute x is 2 pi. Correct. So we got the first term, first bracket, minus. How we got the second bracket? Wherever there is x, we substitute 0, the lower limit. Now remember, in general, e raised to 0 is 1. This e raised to 0 we can write 1. Cos 0 is 1. Sin 0 is 0. Sin of 0 is 0. And remember, cos 2n pi. See, in Fourier series problems, n is always an integer. Cos 2n pi is always 1. And sin 2n pi is always 0. Sin 2n pi is 0. So sin 2 pi, sin 4 pi, sin 6 pi, sin 0, all of them are 0. Cos 2n pi is 1, cos 2 pi, cos 4 pi, all of them are equal to 1. So we can substitute the respective values. So e raised to 2 pi, we are going to keep it as it is. Cos 2n pi will be 1, sin 2n pi will be 0, e raised to 0 will be 1, cos 0 will be 1, sin 0 will be 0. We will substitute the respective values, okay, in the respective terms. So see, we are going to get n is 1 upon pi into this term. So n becomes 1 upon pi into that e raised to pi is going to remain e raised to 2 pi will remain e raised to 2 pi. e raised to 2 pi upon 1 plus n square into, see that cos 2n pi term is going to be 1, sin 2n pi term becomes 0, minus e raised to 0 becomes 1 upon this 1 plus n square as it is, cos 0 term becomes 1, sin 0 term becomes 0. We substitute the respective values, so it becomes 1 upon pi into bracket e raised to 2 pi upon 1 plus n square minus 1 upon 1 plus n square. This 1 into 1 will become 1, this e raised to 2 pi into 1 becomes e raised to 2 pi, so that we can write this as 1 upon pi into bracket e raised to 2 pi minus 1 upon 1 plus n square. So see, this is the value of an that we have got. We have got the value of an. Now we'll find Bn. Remember the formula to find Bn. The formula to find Bn is 1 upon pi integration with limit 0 to 2 pi f of x into sine of nx dx. In an it was f of x into cos nx. In Bn it is f of x into sine nx dx. Limits are 0 to 2 pi. Remember, this is the formula to find Bn for a function f of x, which is defined in the interval 0 to 2 pi. So now in this case, again we know that f of x is e raised to x. So we substitute f of x as e raised to x into the sine of nx dx as it is. Again we know the formula that integration of e raised to ax into sine of bx dx. So we have to learn this formula. Remember, it is e raised to ax upon a square plus b square into bracket a sine bx minus b into cos of bx. So this is the formula. Now, in this case, our problem, if you compare the formula with our problem here, in place of e raised to x, it is e raised to x. That means a is 1. In our problem, in place of sin bx, it is sin nx. That means b is n. In place of bx, it is nx. So b is n. We are going to apply this formula. Okay. So see, this e raised to x will remain outside as it is upon a square plus b square will become 1 square plus n square. And in this formula, see, first it is sin bx and then cos bx. So in our problem, it is sin nx. So it will be first sin nx and then cos nx. In place of a, will put 1. In place of b, it will be n. So see, if we apply this formula, I'll write that step again. So see, Bn is, we are solving for Bn, it is 1 upon pi into integration with limit 0 to 2 pi e raised to x into sine nx dx. So see, this 1 upon pi will remain outside as it is. It will be e raised to x upon 1 plus n square. Remember the formula, it is e raised to ax upon a square plus b square. Or a is 1, so 1 square becomes 1, b square becomes n square. Is e raised to x as it is into, we know in the formula if it is sin bx, first we write sin bx. Now here it is sin nx, so we write sin nx and into a is 1 minus, in the formula it is minus e raised to x sin bx. First it is a sin bx minus b into cos bx. B is n and it will be cos of nx in our case. In place of b, it is n, and this entire term is within the limit 0 to 2 pi. This limit is 0 to pi. Now first we put the upper limit 2 pi in place of x. Whenever there is x, we will put 2 pi. So see, this becomes e raised to 2 pi upon 1 plus n square. In place of x, we write 2 pi, it becomes e raised to 2 pi upon 1 plus n square into, in place of x, if we write 2 pi, this will be n into 2 pi, that will be sine of 2n pi. It will be sine 2n pi minus n into cos of 2n pi. In place of x, I am writing 2 pi. So n into 2 pi becomes 2n pi. This is when you put the upper limit. So see, we have written the upper limit minus the lower limit. If you put the lower limit now, in place of x, if I write 0, see, this will be e raised to 0 upon 1 plus n square as it is into, in place of x, if you write 0 here, it will be sine of 0 minus n into cos of 0. We'll substitute the respective values. Again, remember, e raised to 0 is 1, cos 0 is 1, sin 0 is 0, cos 2n pi is 1, and sin 2n pi is also 1. You have to learn all these values. Remember these values. So we get Bn. Bn is 1 upon pi into e raised to 2 pi upon 1 plus n square. Sin 2n pi is 0, cos 2n pi is 1. See this term, sin 2n pi becomes 0, cos 2n pi we write as 1, e raised to 0 we write as 1, 1 upon 1 plus n square. Sin 0 is 0, cos 0 is 1. So see, Bn becomes 1 upon pi into bracket, this e raised to 2 pi into minus n will be minus n into e raised to 2 pi upon 1 plus n square as it is, and this minus into minus will be plus n upon 1 plus n square as it is. The denominator of both the terms is same. We can add the two terms. We can write the positive term first. So you may write this as 1 upon pi into bracket n minus n into e raised to 2 pi divided by 1 plus n square. Correct. So I have written this plus n term first and then this minus n e raised to 2 pi. The denominator being same, we can add both the terms at the same time. We can take n common. We can take n common from the numerator. So it can be written as n into bracket 1 minus e raised to 2 pi. So we'll get Bn. So we get this Bn as 1 upon pi into n into bracket 1 minus e raised to pi. I have taken n common from the numerator upon this 1 plus n square as it is. Now we know that Fourier series is given by the formula f of x is a0 by 2, or you can say it is 1 upon 2 into a0 plus summation n is 1 to infinity an into cos of nx plus bn into sine of nx. Remember, this is the formula to find the Fourier series or Fourier expansion when the interval is 0 to 2 pi. See, if you substitute the respective values, now a0, see the value of a0 that we had got was a0 value we had got was e raised to 2 pi minus 1 upon pi. E raised to 2 pi minus 1 upon was e raised to 2 pi minus 1 upon pi. That was the value of a0. We substitute the value of a0 plus summation n is 1 to infinity. The value of an that we have got, we found out the value of an and we have got it as 1 upon pi into bracket e raised to 2 pi minus 1 upon 1 plus n square. So it was 1 upon pi into bracket e raised to 2 pi minus 1 upon 1 plus n square. We have found out that value into this cos nx as it is plus bn. See, the value of bn that we have got just now is 1 upon pi into bracket 1 minus e raised to pi upon 1 plus n square. Okay, that value in fact I had written here only. Okay, so plus you can write as n upon pi into 1 minus e raised to 2 pi divided by 1 plus n square into this sin nx as it is. Sin nx as it is. So see what we have done. We substitute the respective values of a0, an, bn that we have found out just now. Now see, simplification is possible. Like from both the terms, you can take 1 upon pi term outside the summation. See, we cannot take any n term outside summation. But yes, you can take 1 upon pi. The constant term you can take outside. Here it is e raised to 2 pi minus 1. You can, yes, here it is e raised to 1 minus e raised to pi here, whereas here it is e raised to pi minus 1. See, you can leave it, the answer here itself. This is your final answer. You can keep it here itself, or if you want to simplify, you can, from both the terms, you can take e raised to pi common. So 1 upon pi common from both the terms, and in the numerator, see, here it is e raised to 2 pi minus 1, here it is 1 minus e raised to 2 pi. If I take minus sign common here, this will be negative, and this will be e raised to pi minus 1. So I just show you what can be done. So you can keep this as it is, or if you want to simplify, sometimes you'll find the textbook it is simplified further. So that's why I'll show you what can be done. We can take 1 upon pi common outside. If you want to take e raised to pi minus 1 common, I'll have to first of all take minus n common from here, and then if I take e raised to 2 pi minus 1 upon pi common from both the terms, it becomes summation n is 1 to infinity. I have taken 1 upon pi common outside, e raised to 2 pi minus 1 outside. So what remains here, it is cos nx upon 1 plus n square. You have taken minus common here, so minus n in upon 1 plus n square into sine nx. So I taken e raised to 2 pi minus 1 common, and if I have to take e raised to pi minus 1 common, I'll have to take minus n common here. This becomes minus n, that this becomes e raised to pi minus 1, which I have taken outside. Okay, as our answer. So see, this is the required Fourier expansion. This is the required Fourier expansion. This will be our final answer for this question. We find the value of a0, an, bn, substitute, simplify as much as possible, or you can leave the answer here also. This will be our final statement. Thanks.